Welcome. I'm Bill Wake. We're here working on an interpreter called, well, I guess the programming language it interprets is called tenth. It's a subset of fourth, kind of. And we're working on the compiler aspect. We've done the primaries, which are the primitive assembly routines. They're pretty simple. You just put them in a dictionary. Now we've got to do the secondaries. Secondaries also go in the dictionary, but in a different section, and they need more information. So we're working on their headers. And we left off with a failing test. So colon writes header to secondary. The x equals 0. This is whether string equal. We got 0. We expected 1. And the string we got was an empty string, and we expected an xy. And let's see, core. So core, colon, all we do is turn the compiler mode, or turn the flag to compiler mode, which is good for it to do, but it's not the only thing it needs to do. What we really need to do, let's see if I can go back here. We want to copy, well, assume this is the last word that was in secondaries. We want to copy the string name in here, then make another copy of this, the link to the previous, the address of the name we just created, excuse me, and the address of start2d, which is the secondary interpreter routine. All right. Let's look at our test. And our test is not full either. There's a bunch of other stuff it should look at, so we got a ways to go. But, you know, I think we have a problem. So I loaded this address x4, which is what readwords uses. Let's see. So I suppose that's in REPL, huh? No, how about eval? Well, no, I guess it is read word. That's input. Okay, yeah, read word expects to get x4 as the address of the routine to call. That is not in, well, colon doesn't know anything about x4. And it doesn't want to know anything about what goes on in read word either. So I think the x4 thing, we put that in for testing so we could substitute out the read method. But I think we really should do something different. I think just like we have a global variable for compiler, here's core defines, compiler routine is x23. I think we really ought to have a global routine for the routine that may prompt, may need a new line, may just go to the word, but that piece of prompt and do a Unix read line, which is an input. Let's see, that's here. Yeah, that's the normal prompt. And notice that this can happen while you're interpreting something. So print and then read a new line. We do 0 input buffer size. Yeah, I kind of feel like maybe this chunk, instead of BLRX4, I think maybe this chunk ought to be a separate routine. And that's the thing that can be replaced. So it's going to have X0, maybe X0, X1 might be nice. Or X1, X2, I don't know. But I think this piece, because colon wants to call read word and not worry about it. Because colon is, you do colon and then the word you want to define and then the rest of the stuff until a semicolon. And the word you want to define, colon's there, it already has read the colon itself. It just wants to do a read word and get the next word so it can put that word in the dictionary. And it's not in a position to deal with passing stuff to read line or anything. It's just not what it needs. Now, X4, we do pass that in. Okay, he's going to call read word. Maybe he can get by with this. Although I still kind of say it would be better if this were included too, because we get prompts in our, when our tests read a new line, force a new line read, they generate a prompt on the printed output, which is a little weird. But okay, I guess if we set X4, then we're okay. But colon doesn't know how to do that. He wants to call read word, but he's not given X4. Yeah, that's my problem. Okay. So I think I'm going to comment out the assertion. So we can do a refactoring. So let's, we'll save and make, it should all be green, including our core. Yeah. Okay. Yeah, this one has no assertion, so no pass, but that's kind of what we intend at this moment. And I don't know, I got to look at registers again. Oh no, I pulled this stuff out so I didn't have to do this. Okay. Environment notes. Oh, no, that's not what I want. Okay, standard registers. All right, so X19 through X28. That tells me we can reserve, well, I don't know what we're up to yet. We'll have to see. X28 defines. Okay, we still got a little room. All right, so I'm going to say define read line as X26. Maybe it's read line routine X26. This is routine that prints prompt and reads next line. Okay, now this, well, today this is in here. Okay, what does he need? He needs X0, X1, X2. Except he could own the input buffer and he could own the size. Okay, maybe he just needs X0. Well, he doesn't even need that. That's okay, let's try and extract a method. I'm going to call it read line. He's got to be global. Ooh, already have a read line. Ooh. Well, maybe this can be inlined. All right, let's take that. So read line, we'll put this here, return. All right. And Unix read is defined in Unix-like functions. Unix read store. It calls the service call, but it doesn't make any routine calls. So we're okay. All right, I'm going to take this off here. And then prompt and that. Now, assigning the word pointer, I think that's not its job. Okay, so let's do this. Oops. Okay, so we'll load the prompt. We'll move x0 gets a 0. X1 is the input buffer. X2 is the input buffer size. That's the equate there. We will brill our X4. Well, I think what we're going to do now, okay, I'm going to break something. Well, yeah, it was, no, maybe not. I'm not sure why. Oh, it was global because it was used when we set up X4. So let's do a global search for X4, but that shouldn't be too much. Well, there's some tests. Okay, what's this? Vector string. Okay, we used it as a temp. X4 is a temp. Load address X4 read line. Yeah, this is the line that does that. I believe that's the only real reference to read line. That might be a better search. Input tests, defined and loaded there. So these tests are doing, they're replacing X4. Okay, so let's, yeah, it was exported for tests and for that global. All right, so I'm gonna, well, I'll comment this out. It's kind of a weird, we're kind of combining some things that are kind of not refactorings, but mostly I'm extracting this method and inlining this because other than test contexts, this is what happens. So I'm really going to replace, actually, this might be fine. I think the effect is going to be those things will call stub read line and don't do any prompting. So I think it'll actually be better. Okay, but I believe, whoops, I'll leave the comment till we get everything straightened out. But I believe this is going to work on the production side. Well, I didn't call it, but do we save things here? Yeah, so let's BL read line. Well, actually, I think this is where our define comes in. What I want to do is BL here. Okay, so let's find this. Okay, he does X4. Okay, well, let me get back here. All right, so I think this routine's okay. What needs to happen here is this all needs to become BLR, and now we need our defined name, read line routine here. Okay, and these were all the ones we pulled out. Okay, so instead of BLR X4, we're going to BLR there. Okay, so now I'm not going to mention this. Well, I guess we could. Read line routine, address of routine to call to read line. Yes, okay. And this is X26. I don't know if I should really say that there, though. I'll say register. Address of routine to call read line. Okay. Now, this, I want this to be that read line routine. Okay. Yep. Stub read line. Simulated line read. Okay. Well, we don't really need that. Okay, let's see what's going on here. Load address this. All right, I'm not quite sure we're complete here, but let's do a make and see how far off we are. Okay. This is input. Yeah. Input test never needed the macros before. I don't remember. Do we need dictionary too? Maybe not. Okay, mostly good. Ooh, looks like it's all good. Oh, there's one. Read with word at start. Okay. I wish I could get that in red. Test that out. Okay. There may be more because that one failed. Input tests. Yeah, there's going to be more. Okay. So, stub read line, I don't think that should be, oh, we made it global for debugging purposes. All right. Yeah, at this point, there really are no arguments to that. Input to read line. He uses X0. I mean, I guess. Does he even make an output? Gotta go back to our Unix read. Oh, number of characters read. Okay. Okay. I think, well, most things are happy. All right. Except for those input tests. Okay, let's make sure this is good or bad, as it were. Okay. Read input test. So our stub read line. X1 equals input buffer. I don't know. That's being ignored. X0's file descriptor, that's really not being used that way. We trash X0 line 109. Okay, so I mean, I think the only thing that should be true is output is X0 equals number of characters read. All right, so let's look at the test. We initialize input. We do something to initialize our stubs. Read index. Read index, what's that? Oh, that's the index. Well, I'm not sure what this is doing. It loads the address, X9 is LRead index, and then it gets the value there. That's the pointer to what it wants to read. Oh yeah, because we had an array of stuff somewhere. Maybe it's just this was an array. And they're going to have the addresses of the strings they actually want to read. Okay. So we get the current index, which should be 0. Oh, no. Yeah, we're getting we're reading the read index. We load read source. Get the address of the read source. That's that's those strings. And then we load this plus this times 8. So, okay, the index is the number of the item in there. So we multiply that by 8, add it in, and that gets us the string that gets pointed to there, and we copy it. Okay. But then the actual read, X10 gets contents of the read index. Okay. Add X10 gets X10 plus 1. Okay, next index gets increased, and we store that. Okay. But I guess this somewhere here, X0 okay, so lreads X0 points to the string we want to copy, right? All right, so I think down here, we haven't trashed X0 yet. X0 points to the string we want to read, but we just want to know the length. I think we can just return that. X0 still points to it, BL string length. And that leaves the length of the string in X0. Maybe I can do that here. Okay, I'm going to clarify my thoughts a little here. Okay, so get the read index, get the address of the string, maybe it's current string. Well, really, it's copy the current string. Where are we going with this thing? Well, I keep having to open this Unix thing, but Unix, nope. Unix. Oh, this is C-like. Copy string. Copy string Z. Uses, oh, does not return anything. X0 is the source, X1 is the target. Did we load the target in somewhere? Yes. Oh, X1 is the input buffer. All right, so maybe data segment, let's make an L input buffer because that's where it's getting put. I don't know. Maybe it needs to go to the real input buffer. Actually, that probably is its job. Right, so input, readline's job is to move stuff to the input buffer. Okay, so let's make sure input buffer is global. I hate to kind of expose it, but it really is what our tests need to see. All right. I mean, you can do linker tricks to get this less exposed. So by linker tricks, I mean most linkers have ways to exclude or include symbols. So you could only include that as a global in the test build, but not the production build. I'm just going to live with the fact that stuff's a little more public than I wish it were. Okay, so now simulate line read. There's no input, none, but the output is next line written to global input buffer and x0 equals number of characters read. Okay. So to do copy, we need to set x1. Input buffer. Okay. This might be off by 1. Okay. And then this is move to next string in the input array. Okay. Now I'm violating the assumptions of all of these callers, but I think what we're doing is very close to what we want. All right, so I think that should do the job there. And now stub init, blah, 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 read line routine, load address, read line routine is stub read line. Okay, we branch to read word. Okay, I'm going to say I think that'll give us more what we want. Well, let's do make. Okay, input tests. Oh, they're all passing now. Okay. The thing that's not okay, unless I did it without paying attention, in here, read line routine is read line. Okay, that is okay. All right, so make sure everything looks good. Okay, so I would say we refactored read word to extract an a read line method that handles prompt and read, and then added register for oops. Let's get the word right. Read line routine. Okay. Kind of a well, touched a few things. Okay. But I think that makes us much better off in our colon test. So let's take the diversion from that. Well, I don't think he needs a lot of lines. Whoops. Okay. Now let's go back here. Do our assertion. It should still fail. Okay, I saw red. Okay, good. Okay, so a little diversion to refactor. So we're kind of making it possible for colon tests to write a new line somewhere, and they can do their own read line function. Okay, so core test colon writes to secondary. Okay, this is not useful. It'll read words. X0 will count. Wait, X1 is address a buffer. Is that? That's not how we did it, is it? It has no inputs for X. It uses the address the read register. Okay, so something's not consistent there. X1 is the address of the buffer. Well, X0 is not 0 either, so L colon test string. All right, I think X1 was not passed in, so we need to set X1. All right, so load address X1 is input buffer. Okay, I think that's what it should look like. L colon test string, which is X, Y, should go in the input buffer. String copy Z does the write. Okay. And all right, this still is going to fail. Not quite like that. Input buffer referenced from core tests. I think that's probably our make file. So core tests does not depend on input.o, but it needs to. Yeah, I mean, I guess we could pull that into a separate module or something, but not helpful. Okay, so all we've done is said if you called our routine, you would get XY copied in, but we don't call our routine. Well, no. Yeah, maybe it should. That's probably a good point. Cortez, well, he should need to end with something. I think that might be enough. Because read word is just going to read the XY, hit the space and say, okay, that's a word. I'll substitute a 0 there. So I think you're right. A new line would work, but I think a space is a little simpler and it will also work. Okay. And now we do this and we're looking for that string. So I believe we're finally ready to actually change core, change the colon routine. Okay. So we have, let's see, where's my other? We should have secondary space should be pointing to the next place to write. All right, so let's make sure that variable's there. Okay, x25. Secondary space is where to write secondaries. Okay, that, well, does our test own that space? I guess it does. That's this, L-test secondary area. Okay, so low dress secondary space. Okay, so that is there, ready to go. All right, so we should be able to well, we don't have a string copy. We got this string copy Z, but I think it's probably okay. Okay, so X20, sec space is our secondary space. That's the target. The source is the read word. Okay, so we need to do a read word, and X0 is going to point there. Okay, so what's X22? I think that is word pointer. Word pointer. I'm going to do it like that. Okay, and at the end, word pointer. Store byte, what's there? Store 0 at word pointer -1. Okay, I think word pointer is pointing to the next word, but X0 is pointing to the word. Do we capture that somewhere? Well, I guess that'll be a thing we get to find out. Okay, so at any rate, I think in here, we got to get the word pointed to is going to be X0 if we do a read word. So we read word. Okay, so we got the colon read, so we're reading the next word. And X0 is where it points. Okay, so that's somewhere in our input buffer, and we need to do a copy of that. Well, X0 is the source. That's the word we just read, so that one's okay. But we need to get X1. Let's move X1 equals secondary space. Okay, so that's the first free word in our thing. And if we call string copy Z, again, I'm kind of too lazy to have string copy at this point. I'm not worried about spending one more byte really, so I'm not, that's why I'm not, it costs us a little space, but it doesn't really mean anything. Okay, so we're going to move that word into there. I think that's sort of the first part of this test. Yeah, read word. Okay, core.o, data stack init. Well, core tests. Wait a minute. Who failed, core or data stack init in core.o? Data stack init in core.o. I don't think I see any sense there. Undefined symbol for read word in core.o. Okay, let's see. Well, there's no core.o. It shouldn't matter till we link. This is the LD-O dictionary tests. Okay, let's make sure those dictionary tests .out depend on input.o, which is kind of true. All right, there may be more. Yeah. -O interpreter test.out. And this already has input.o, and that doesn't need it. Okay, so maybe we're done. Yeah. All right. Boom. Segmentation fault. Okay. Okay. Core tests. So, that was the first one. Okay, we don't have that stuff set up for him because we've made it now. You really do need secondary space defined. Well, and this should be input routine, read line routine. But we didn't run that far. We don't have this defined or that defined. Copy test string. Oh, well, yeah, that you almost can't test that anymore. Okay, we're going to read a line though. It'll default to reading the XY, but we're not testing it. We've broken it because test colon does a lot of things. Colon does a lot of things, so I'm gonna let I'm gonna assume the tests. I'm gonna use a series of tests to cover all those things. Okay, so let's try again. Colon switch to compile mode segmentation fault. Okay, let's do LLDB core test.out. Run. See where he really falls apart. Wow, that's not much of a memory read. 0. Oh, colon switches to compile mode. Oh no, that's where it died. Okay. Where? Well, okay, let's break set minus B. This. Run. Yes. Okay, so these first few. Next step. Okay. Now, that's not promising. X24. That's secondary area. Is secondary space? Wait. Colon switches to compile mode. Core test. Colon switches to compile mode. Okay. Oh, move flags to run mode. Okay, that's X24's flags. We'll step. And then we BL colon. All right, let's step into his step. Okay. There's that. All right, now we do a read word. Okay. Let's read. He should call read word. Okay. Well, let's do a next. Skip over this and see if it blows up inside read word. Yeah. Okay. Run. Yes. Okay. Step. Step into read word. Okay. X30. Okay. Reg read X22. Okay, so he's pointing somewhere. Input. Read word. Word pointer is pointing somewhere. Okay, step. 3F58. No. Okay, so X26 is our input routine. Then we get back NERP 322. Okay, we're loading input buffer. So let's go in. Now this should be our stub reword. Okay, boom. X26. Okay, I'm a little confused. Read line routine. Believe we set it up in our test. Maybe I forgot to make colon switches to compile node. Okay, there's read words. Yeah, that's really kind of a read line, but okay. X26 did not have this. Read line. Why not? Yeah, I mean, I think we've set it properly. This is L read words is our routine, so it should be pointing there when we get there. All right, let me quit and make sure I did a make. Okay, break set minus B. This. Well, you know, I keep looking at the wrong code too. Okay, colon writes header to secondary. Yeah, that thing should do it. Okay, so let's run. Step, next, step. Okay, now we're in our routine. We move x24 gets x24 is the flags. Well, what are we in? Colon switches to compile mode. Cortex. Yeah, I keep reading the wrong thing. Oh, we didn't. Oh, wait a minute. Where's that code? Oh, that's read words. Where's my test? Oh, he does not do that. Okay, yeah, this is read words. That's not where this goes. It was supposed to go up here. Okay, that's not even in our code, so there's no wonder that's blowing up. Okay, core. All right, colon switches to compile mode. Passes now. Woohoo. Oh, really weird. XY. XY space. We didn't. Thank you. Yeah. How long that'll take. Okay. Well, maybe we got to assert against final, and that should be the real one. Okay. So colon writes to secondary assert equal string should be this. Okay, so what I saw here is this. Well, yeah. If I click to the end of the line, I got a space. But here I don't, because when it pulls it, it does write a space, a zero over that space. So I can't use that as my assertion without screwing around a little bit. Okay, and they were in, yeah, they are in data, but yeah, don't want to mess with it. Okay, let's do it this way. So we know for sure it's a separate string, and we're not pointing to the wrong one. Okay, now make Cortez pass. All right. Now we know there's more that has to happen for that character to be right. So all we've done is written the string. We don't have anything. Okay, LTSA, the load test secondary area, plus 8 should be the same as the old dictionary pointer. Okay, we're definitely not doing that. Dictionary pointer should be updated. I mean, I think the real thing is the secondary space should be, well, let's say it was starting at 0 and we wrote less than 8 bytes. That thing should be secondary space plus 8. Okay, so load address x0 is L test secondary area. Okay. X0 is that. No, we want the. Well, that's our free space. I think this is X1 though. X1, let's move X1 gets secondary space. Okay. And I'm going to add X1 gets X1 plus 8. Okay. So I'm trying to. Test breaks is not the one. Okay, I'm trying to make sure the secondary space pointer is equal to the secondary test area plus 8 because we wrote less than 8 bytes, even counting our double zeros. Okay, so that should be assert equal. That's going to fail. pretty sure. Make, and then let's just do ... core tests. Okay. Yeah. So we see the actual value is 384 and the expected value is 392. So we did not increment by 8. It just is left pointing to the thing. Okay. So now what it's supposed to be doing, all right. So colon again. Where are you? Okay, so secondary space should be updated by the length of that string. Now, string copy Z, this may be a, I mean, it honestly should point to the string it results in or something. But yeah, we're going to check the length of the copied word. Okay, so I want to say secondary space. X0 is the what? We'd call read X0 is the word. Okay. We copy the word in. Copy destroys our word, but we care about the one in secondary space. So let's move, move X0 gets secondary space. Okay. And now that is pointing to the start of the word we copied too. Okay, so let's go string length. Okay, so now we know the length of the word we copied to. And that's back in X0. Okay, so let's start commenting. Okay, read the word to be defined. Copy the word after the last secondary. Okay. Adjust secondary space to account for copied word. Okay. All right. So now X0 is the string length. So we can, let's make X0 equals X0 plus 1. Okay, because we have the string length, we got to account for a 0 at the end. If we wrote 2 zeros, it doesn't matter. It's going to get thrown away. Yeah, we got to be mod 8 too. Okay, so now I've got X0 has secondary space plus the string length plus 1, accounting for that 0 byte. Okay, and then we need to, well, I'm not sure whether to do this in X0 or X1, but we need to make sure adjust sec space forward to address mod 8. Okay. Because we need our header pointers need to be aligned on an 8-byte boundary. Okay, because they're 64-bit entities. All right. So X0 is the value we want, but if you increment, I think what we can do is increment well, we really want it to be, I don't want to be confusing. I think we got to clear the lowest 3 bits, right? I don't think it'll matter much, but I actually think this should be 9 and then truncate. Or I think we can do this. All right. So I'm saying you're pointing at the last byte. If you increment by 8, right, that's the 4th bit. Let's see. Well, what I'm going to do, I should say what I'm going to do, and then we can argue about it. I want to make secondary space be x0 and -8, I think. Okay, so let me see if I can, I don't know if I can write -8 equals. Not so helpful. Base 16, yeah. Okay, so -8 in this ends in F8. So all the F's are 1s. Oh yeah, you got it right here. All the F's are 1s, and then the bottom 3 bits are cleared. So we're ending with that. So anybody who's a 1 up here will get a 1. If there's 0, this will be a 0. Down to here, where that bit is always going to be cleared regardless of what it started at. Same here, same here. Okay, so I think that does that. All right. Now, did our test require that? I don't think we quite did. Oh, it does. Yeah, because we're adding 8. We're saying it should be 8 more. 8 bytes more than the original. Okay. Now, I don't know if it's going to matter the order you do things, but you got to add string length plus 1 is going to be wherever we are in the bytes. If we're at, well, okay, let's run it and then we'll argue. And I guess this deserves a comment too. Set flags, change to compile mode. Okay. Can't do it. Okay. I could have sworn they said they could, but that was probably the other assembler. Okay. Plus extra word. Copied bytes plus extra word. Okay. X0 gets X0 plus 9. Well, no. Wait a minute. X0 gets sec space. No. What am I after here? I want to get, I've got the length. X0, X0. Well, that's going to be more length. I still got to do an add, don't I? Well, maybe this is better. Okay, so if I have X93, I have X0 is the length. It's secondary. Oh, it's only the length. Okay, so I'm taking the length, increasing that. Now I'm going to add secondary space equals X0, which is the length. Well, no, is it secondary space? Yeah, it's got to be the old secondary space plus X0. And I still have to add that 8 in, so I guess it's going to be up here. Okay. plus 1 byte /0 plus extra word. Okay. Yeah, I mean, I think because I want to add both, I really want to say x0 equals secondary space plus x0 plus 9 in the end. then and this. Okay. What was my complaint? Invalid operation. Okay. And it still failed. X0 equals 8. Well, that's x0 equals 8. So secondary space equals 8 is 0? Equals 8. I don't know. It's like I'm not, like I cleared out secondary space somehow. X0 gets secondary space, call string length. That should leave secondary space alone, but return x0 being the string length. Okay. Secondary space equals secondary space plus x0. And okay, so well, we know where to check, right? Let's stop in here. Core test.out. How weird. Okay, let's stop here. Oh, I think it strips off these. Okay, run. All right, well, continue. This is the test. Oh, wait, this is core. We definitely want to continue. I guess. Okay, now we're in colon right to secondary. Okay, that's the first test. Continue to get to colon. Okay. I think we'll step next, and then we're move x1, x25, string copy z. Okay, so let's reg read x25. All right, that's our test area probably. We'll step reg read x01. Why x1? Oh, are we about to do string copy z? Oh, let's skip over that one. Okay, x0 gets x25. Okay, step rig read x0, rig read x25. Okay, we'll go over string length. Okay, reg read x0 is 2, right? That sounds good. X0 is the length of xy, and then we got to add stuff to it. Okay, so step. Oh, I'm still. Plus 9. All right, reg read x0 is b, which is 11, which is 2 plus 9. Okay. And now let's read x25. That should still be that. Yep. Okay, so if I add x25 plus x0, I should get 401b. Okay. And then when I AND, x25 is, oh, that should be x25. Because we've got x25 is already, x25 is the old secondary space plus x0. And now we want to AND secondary space with -8. Okay. Make core tests. Here we are. Okay. Yeah, we were okay. All right. Right to secondary. Okay, so that's, I don't know if this is getting obnoxious, but all right. So we've copied the word to be defined after the last secondary. Okay, so secondary space plus AND it. Okay, so now I want to kind of think through, if I had a 1 byte word, read word always gets at least one character. So if I had a 1 byte word, x0 would be 10. 1 plus 1 plus 8. All right. Now, let's say secondary space started at 0 just to make things easy. All right. So I'm looking at 10 versus 0. I'm going to add secondary space to x0. So it's now 10. And then I'm going to strip off the 3 bits, right? 3 bits. Okay, so 10 is really 8 plus 2. Okay, so the 8 is fine, but the 2. So it's really 8. All right, so the minimal word, that works. So we put in a 1 character word or a 1 byte word. It takes 2 bytes and it fits at the next address being 8. Okay, now let's take a 7 byte word. And I don't know if I should just like arguing my way around it. Okay, but if I take a 7 byte word and I add 9 to it, I've got 16. Okay, so I add secondary space to that, get 16. I take off the last 3 bits, 1, 2, 4, it's still 16. Okay, so that seems, is that legal? I don't know. Let's, I don't know, the test is so, okay, I guess if I have a word that's 1 to 7 bytes long, right? Then it's going to take 8 bytes and it should be 8 bigger no matter what. If I had one that's 8 bytes long, okay. Oh, should I make this? I think it should work. Okay, 7 plus 1 is 8. 7 plus 9. Are we doing that? The core. 7 plus 9, 16. And that's into the second. I don't know. That doesn't sound right to me. Is that right? 8-byte long word. Well, let's, if it's 7 bytes, right, then 7 bytes plus the 0 is 8 bytes, right? So why should that be? I don't think it should be plus 16, should it? I'm questioning my mod math. All right, so if it's a 1 through 7 is really 2 through 8. Okay. They all take 8 bytes or less, so it should bump by 8 bytes. And then 8 through 15 is really, well, I don't care about if it's 8. Well, if it's 7, no. I guess 8 through 15 should be bumped by 16 bytes, right? Because it's got the 0. I don't know if I'm calculating it. I don't know why it's 9 through 16. Oh, an 8-letter word. Okay, yeah. 8-byte word plus 1 is 9. Okay. So yeah, I think I'm doing something off here. All right. So if I want 8, I think I'm not sure adding that 9 is the right thing. Maybe it should be a 7 plus 1 is 8. You know, because I think if I add, well, like the tricky case is 8 bytes, right? So if it's 8 bytes long, well, no, really the tricky case is, yeah, I guess the 8 bytes is probably an interesting one. So 8 plus 17, plus 9, 17, that's going to bump it by 16. But 7 is 8 plus 9 is 17. That bumps it by 16. So that's too high. I think that number should be 8. 1 plus 7. I think I'm making it extra big. Now, how I can test that in a test? Okay, yeah, let's see. If I'll just modify the test briefly and then we'll go. If I do 7, a 7-letter word, which is really an 8-byte thing, it should bump forward by 8. Okay, so let's modify this test. X, Y, 1, 2, 3, 4, 5, 6, 7 plus a new line. 1, 2, 3, 4, 5, 6, 7 plus a new space, which will be in /0. And this should be 3, 4, 5, 6, 7. Okay. That should still be 8 bytes. That should still be 8. And I think it's going to turn out to be 16. That's also, yep. Okay, 672 instead of 6. Yeah, it came out 16. All right. And let's change this. Well, let's make 9. Let's make a 9 while we're at it. 8, 8. And this should be 16. Okay. I'm not going to keep all these variations, but okay. Yeah, so that's okay because it's too big. All right. Let's do this back. But I think the test that's exactly that is probably useful. And This is going to fail, right? Make sure back where I was. Yeah. Okay. I believe +8 is the target we should be going for. All right. Yep. Okay. And I guess that almost makes more sense in a way. Well, no, it doesn't. It really is 7 because if you get 1 byte into something that has to be 8 bytes, this 8-byte word is ruined. Okay. And you would know that if you added 7 to it because that would push it to the next word down, which would be okay. So I think I guess this is 7-byte buffer or something like that. 7-byte. Yeah, let's say buffer. Okay. It's, yeah, should be +8. So this should be 8 and the test should be 8. Oh, wait. Oh, that was 9. Okay. Why did that it pass? Because it came out 16. We want it to come out 8 because this takes 7 bytes plus 1 is 8. And it should be fine to go to the next word immediately. Okay, I think we're good. Core test. No, we're not. Oh, a bus error. Okay, let's see if I'm convinced in the code. Okay, so if you were to somehow take 1 byte, I'm going to add, you've destroyed a word, so I'm going to add 7 and get to the next legal word. If you took 7 bytes, no, if you took 8 bytes total, I'm going to add 7 and then truncate to the 8. So 7 is 15, truncated to 8 is 8. Okay, now line 89 should be 16. Oh, sorry. Oh, right. Yeah, I keep getting on the wrong method. Okay, this should be 8 with a 7-byte word plus the extra. Yes. Okay. Thank you. Good. All right. So ACP, write string before after last secondary and around sec space pointer mod 8. Okay. Which is to next 64-bit word. All right. And I think I left a little comment in there I don't need. No, I deleted that. Okay. Right. So I think the good news is here we've successfully written out the word we want, and we're ready to write into our secondary space. Now, the one thing we've done though that's bad, we've forgotten we've forgotten where secondary space was, the old value, because we still need to point to that word. So I'm going to say, I'm going to keep X1 around with that. All right, let's work on the next revision of this. Okay, plus secondary. Okay. Yeah. So dictionary pointer. I don't think we're looking up anything, so we can make up a dictionary pointer. All right. So now, okay. So secondary space. If we take secondary space is where the previous link should be, which is the previous dictionary link. All right. And we don't have to, we can modify that a little bit. We don't have to set up the dictionary to do it. It's just supposed to copy it in. So the variable for that is 20 sysdict. All right. So the test should be, well, let's move system, some dictionary gets, let's just say 48. No, it's big power of 800. Okay. It's got to be divisible by 8, and I don't want it to overlap our test area, but it doesn't have to be a real thing. Can I AND x0 with -8? I don't think so, because is that going to work? I mean, x0 is 2, ANDed with -8. Well, I guess I got to worry about if x0 is, should be the same. Okay, and x0 with -8. Should it be the same? After I add the 8. So, can you AND x0 with -8 and use that as the offset? Well, I have to add it back into secondary space though anyway, right? So x0 is mod 8. I don't know if I can cut out a step here or not. I mean, I'm adding twice, so that sucks a bit. Can I AND x0 with -8? Well, x0 is a number. Okay, it's a low number, right? So x0 with -8 is going to strip off the last 3 bits of x0. Oh, for the next phase. But then I have to add x0 at some point. Okay, so I think what you're saying is and x0 is x0 and -8, right? and then hold off. Okay. And then do the other work in here before we add it. Is that what we're saying? I think, are you saying this would be equivalent to what we had? But I can do sec space plus 8 and plus my constants. Oh, but no, I need to do that after I'm added, I think. Right, well, make sure it's equivalent first, but I think the order is going to have to be different. Core tests, colon tests, yeah. So I think that's okay in that sense, but I still have to do this before I go because secondary space is the point is now the pointer to the dictionary entry we're going to create. So unless I can add it off x0, but I think I'm better off just having it. Okay. But I should be able to do this then, right? Oh no, that's ANDed. Yeah, but then next I need that plus 8, and I don't think I can get three things added there, can I? I go back to my addressing modes, which are conveniently right here. Okay. I can do a shifted. Yeah, I don't have a thing that's going to let me do a literal plus a pair of registers. Kind of too bad. Yeah, I get the offset one, but yeah, I think I got to compute it before I go. So I think I can put this here and then maybe make this part of the comment. That's a little too a 64-bit boundary. That's really what's going on. Okay, and then x1 is, oh, but it gets destroyed by string length. Okay, let's get this. Okay, at x8 after the first store. You could add 8 to x0 after the first store. I'm not sure what you mean by store. Okay. I think I could do this, move this down here just before it changes. X1 equals old security secondary space, then adjust this based on x0. Okay. I think this is legit. Let me run these again. Okay. And then reorder sec space computation a little, save old value in x1. All right. Well, let's take a break. We'll come back and extend this test for the true dictionary pointer stuff. And make sure that the contents of those three cells are like they should be here, these three cells. All right, so see you in 3 or 4 minutes. Welcome back. All right, so we've got the first two asserts. Let's get this dictionary thing in. In our case, the dictionary pointer is 800. Okay, so this, if we, let's see, well, we're going to call something about assert equal, and expected is going to be 800, and we're going to load x0 is L test secondary area. Okay, so well, maybe it's secondary space. First which point is previous secondary. Well, it's I think the thing is we're going to have a dictionary pointer going in, and I think on the first one it's going to be pointing off to the primaries, which are in a different area, but the value of the dictionary pointer should be written into the first cell. So the old dictionary pointer should be written in the first cell, then the pointer back up in the little string we just wrote, and then a constant start2d pointer. Okay, so I guess after colon, you're here. I don't know the best way to make this, say this. All right, well, okay, what I'm doing is I'm saying the secondary test area, we know that plus 8 should be the address where the pointer is, because we put strings in the first 8 bits. Okay, so if I add x0 equals x0 plus 8, okay, then the string is up here in the first 8 bytes. Address plus 8 should be the old dictionary pointer. But that, well, that's this constant. Okay. If I load x0 with the contents, is that right? Contents of x0. So if I go to the secondary test area, point there, move down 8, and load the cell that's at that point, that should be equal to the old dictionary value, which was 800. Okay. This will fail. So let's see what the assert is. Assert first cell is a pointer to old dictionary. Okay. And the dictionary pointer should be adjusted. To point to the first cell of this, right? So that's secondary plus 8. A little duplication, but I think it'll make things clearer to understand. Okay, so let's see this one again. So if we take test secondary area plus 8, it gets us past the string. We load the contents of that. That is loading the contents of this cell, which should point to the old dictionary, which we set to 800, kind of arbitrarily. And then, so this should be 800. The dictionary pointer itself should point to here. So it should point to that starting space plus 8, which is here. Okay, so I think that's what we're saying there. All right, and both these are going to fail because we don't do any of that, of course. Okay. Move X1 gets. Did I get that name wrong? System dict. Okay. Okay. So yeah, we did not get 800 in the slot, and we did not update our dictionary pointer, which maybe is a better word. Okay. So we need to put old dictionary at first slot. Okay, so secondary space points where we want to do that. So we want to say store system dictionary at secondary space. And then I think I'm okay to post increment here. Well, let's use X1. No, this is secondary space. That's correct. Okay. And then update dictionary. Well, I want to move system dictionary get secondary space is kind of the previous space. Maybe I gotta take the post increment off. Okay, so store the system dictionary at secondary space and then change the system dictionary to be secondary space. Maybe I can do stuff at the end. I'm going to add, secondary space equals secondary space plus 24. Okay, for those 3 words. Okay, is that reasonable? Okay, so store the system dictionary, move the system dictionary. And that's kind of what I think we're testing. Okay, we got one of them, but not the second. 584. Oh, X1. Wait, am I coming out and looking at secondary space? No. 437095884. That's 24 off. So that sounds like I am comparing secondary space somewhere. Dictionary pointers should be updated. All right, so the secondary space, x1 in secondary space plus 8. Sorry, store x1 in core. Yeah, that's our next move is to write that second slot. But my first one's wrong because it's like dictionary is secondary space. Let me check my assertions first, I guess. Okay, so secondary test area plus 0 is the string, plus 8 should be the dictionary word. So this, oh, I didn't load it? Is that all it is? Secondary test area plus 8 should be the system dictionary. No, I think that's correct. Because it should be the address plus 8. And that should be system dictionary. So something's funny here. Address plus 8. Okay, so we load the secondary test area into X0. We change it to address plus 8 because that's where the system dictionary ought to point to. Now this word got the right thing there, but where's the 24 coming from? I mean, I had a 24, but it was after the dictionary. All right, let me make sure I saved and... Oh. Okay, he's 48 versus 24. So the real one is 24 bigger than I think it should be. Well, that seems wrong. Oh, maybe you're right. Core test. This should be that should be the pointer. Well, that's my actual. I mean, really, this should be the other way around. It doesn't change anything, but maybe it will make me think better. Okay, so the test secondary area, if we have a pointer to that, that's x1 at first in 121, then move it down a word, it should still be the pointer to that area. If I load the contents of that area, that's going to be the old dictionary because that's what we did here. But now I'm saying the new dictionary should have the address of that place. All right. Now it should fail, but the other. Sorry, make sure I'm on the right thing. Okay, so the first one is bigger than the second by 24. System dictionary stored the address in X0. Well, the old system dictionary, yeah. So that's this. So we take the address. This plus 8 is the slot, the first slot, and then we load the contents and we make sure that's equal to our starting dictionary, which is up here. But which is a pointer of some sort. We don't really care about the contents of where it points to originally. We're not looking in there. Okay. So system dictionary should be pointing to the second slot in that secondary area. Am I talking about the right area? Let me make sure. Yeah, the test secondary area. Right, the address is the address of that area, the address plus 8 should point to the first slot. Yeah, plus 8 for the string. And so then that should be the first cell here is this link. And the system dictionary should point to that cell. All right. Why it's off by 24 when I just added 24 is super suspicious to me. Do I have the right variables here? Load system dictionary. Did I save backwards? Core. Store the system dictionary in the secondary space. That's good. And now the system dictionary gets secondary space, which is the true value. I mean, it's the adjusted value. Should be the first slot. Should be the address of the first slot. We didn't change secondary space here. But then we add to secondary space, and somehow dictionary gets bigger. We'll make sure there's no secondary space is 25, system dictionary is 21. So I'm not overlapping anything. Okay. I guess I will debug. Okay, so LL, I guess bang LL should be good. Break. On the second test. Okay, so we'll step, next, step. Gets us into our routine. I guess I want to look at colon. Right. So it's something down here. Okay. Break set minus B colon. Continue. Step, next, step, next. Okay, regex 0 should be 7. Yep. Okay, so step. Add x25 plus x0, step. Okay. Now my store, let's look at system dictionary is x21 and read x21 system dictionary. Okay, 3 times 16 is 480 plus 20. Wait. Sorry, that's 16's. Hopefully that's 800. Gotta be close, right? Okay, 800. Read x25 is the system dictionary. No, x25 is secondary space. Okay, so secondary space points at 4018. All right, so we're going to store. Okay, so let's do mem read count 100 minus OX. Well, it's just this. I guess 4010 is the start, right? So we should see our string x2, 3, xy, 3, 4, 5, 6, 7. Okay. We haven't written, what's this stuff? 6FDF. I think that's just junk. I don't know, maybe. I'm about to write x21 into memory location 4018. 4010, so 4018 is here. Okay, so we'll step, do the mem read again, and we should see 3, 0320, right? Yeah, that was our number. Okay. That's our old dictionary is 500 or 800 rather. Okay. Sorry, let's look at the code again. Okay, so we did that store. Now let's see our dictionaries. Reg read X21. That's our dictionary. X25 is our secondary. Okay, that stays where it is. Okay, so the next step is move X21 gets X25 because 4018 is the address of the next dictionary entry. Okay, step. And then look at the memory. Oh no, look at the variables. Reg read X21 is 4018. So, okay, so do the mem read. Okay, so the old dictionary is stored here. The new secondary space pointer is now the dictionary. Okay, so I'm puzzled. Okay, so we did a store and a move, and now secondary space, that should be X25, right? Let's make double sure. Secondary space gets that plus 18, which is 24. Okay, so X25 should be changed. If I step reg read X25, it should be 18 bigger. 4030. Right, because we got a word here for the string pointer we haven't filled in, and another word here for the routine. So I think, I mean, to me, that stuff looks all right. All right, so let's make sure X21 should still be 4018. Okay, so I'm puzzled. All right, so we're going to go out here and everything looks fine. And then we get back here. I guess we're going to have to step out. X24, what's that? X24 gets flags. We set the flags and step out. Okay, so it's step, step, and we should be back in our test. All right. Now let's make sure reg read X21. Good. Reg read X25. Okay, so if it's our test. So we're here, and these two variables are right. Now, why would they get changed? Assert equal strings should not change these variables. X0 gets secondary space. Okay. And we're not changing any of those important registers. All right, let's skip over these. Load addresses. Okay, so step, load address 2. Skip over this. What did it? Right, rote pass. Okay. Reg read X21. Reg read X25. Good. All right. Move x0, x25. Okay, so we'll load secondary space into x0. Step, step, step. Add 8. And next, I should get a pass. Oh, that's our fail. Oh, we broke something sooner. Oh, well, this is right. This test has got the old value. So, okay. So we're doing the whole adjustment now, not just the adjustment past the string. So I think this should be 32, right? That's 8 bytes for the string, 3 times 8 bytes for the header cells. Okay. Core, there we go. Okay, 4 assertions, good. All right. Okay, next test. We're going to finish this one hopefully today. I think today. All right, we tested the dictionary should be updated. I don't need this last assert equal because it's going to be part of this. LTE SA plus 8 should be the old dictionary pointer. We did that. Okay, so now I'm going to check the contents of the next cell. So okay, so well, I picked about the worst one to duplicate, didn't I? Let's take this one. Well, no, that's the one that's no good. All right, the second cell is this plus 16. And the contents of that should be, well, we're going to have to load address x0l test secondary area x1. Okay, so the second actual cell is test area plus 16. So plus 0 is the string, plus 8's the dictionary, plus 16 should be the second cell. Get the contents of that cell, and that should be pointing back to the string pointer. Right, and that should fail. Okay, yeah, the last one fails. Good, because we left it zeroed out. Oh yeah, I could, couldn't I? Yeah, well, it's okay. We know the dictionary's pointer is correct. Let's use it then. Okay, so this is load x0 gets contents of system dictionary plus 0, 8, right? Second cell. And that should do it. Take the system dictionary, should point to the first cell, plus 8 is the second cell. That should be equal to the pointer to the string. Okay, I believe it. Same failure, good. All right, now core, put the old dictionary at the first slot. Put the defined word string in the second slot. Well, put pointer to word string in the second slot. Okay, that's x1. Well, this is really pointer to saved string. Yeah, it works in either one. Okay, so pointer to the word, oh, that's, okay. The pointer to the word string, we're going to store what? X1 at secondary space plus 8. Okay. That should do it, right? Core. Okay, yeah, 5 assertions, good. Okay, and then the last assertion, assert third cell points to start to D. Okay. +16 and load address x1 is start to D and assert equal. All right, and then start to D is an interpreter, I think. And that's a global, so this should compile and fail. All right. I don't need x1 anymore. Or x0. I guess x0 is x0 get start to D and store x0 at secondary space plus 16. Okay. Sorry. This, oh, you're saying here I should be using dictionary. System dictionary. Yeah, good. That sort of reasserts that our dictionary is correct. Okay, this should pass. Core tests. Okay. All right. It's a little long. I mean, it's the heart of our compiler, so it's not that bad. I think all the steps are kind of okay. I mean, maybe this is worth one extra comment. Pointer to saved string here, just that one's kind of out of flow in a way. Okay, so we have to store the string, adjust the secondary space, store the dictionary at secondary space, update the dictionary, add the 2 word headers, and go. Okay. I don't think. Okay. Here's what I think. All right. So that made and ran. So let's save it. Store all slots in header. Adjust secondary space. Okay, now I'm going to run. No, let's see. Make REPL. Boom, we haven't run that in a while. Okay, let's get to REPL. Oh, include assembler macros. Invalid operation for instruction. Oh, is it main.o? That's complaining. Well, I guess that makes sense if we haven't run the REPL for any of this. Include assembler macros. Oh. Include core.defines. And make that an F-pound include. Main.o. Okay, I can't tell what's what. Main.o does not recognize system dictionary. Oh, maybe dictionary has to be included like that too. Because dictionary uses these variables. Okay, yeah. All right. So I think if you say colon, new word, semicolon, I think this should be okay. Oh, close. It swallowed it, but it's not doing it right. Oh, okay. Let's push this because we got those changes. Make REPL build, but doesn't run, but doesn't colon and semicolon not yet working. I don't know. So, okay, does it wait for more input? I don't think it does. Let's run it again. Okay, so if I do colon, new word, semicolon, new word, I would like that to at least run. Yeah, something's not. Okay, we can tell where it blows up though, right? If I do this, I should get a prompt. Now this could be an IO thing. Did we, oh, or maybe it's a register thing. Have we set up all our core registers in REPL? This I've marked TBD, but they do need to all be set. System dictionary. Okay, let's go to REPL. in a way, I don't think X28 gets next word. X28 is temp, right? Yeah. Okay, REPL. Yeah, we haven't set up all the dictionaries yet, or the words, these things. Okay, so system dictionary, that gets set up. Word pointer compiler routine, but I don't know about this, and I don't know about that. That's the one I'm most worried about. Main.s. Okay. Load system dictionary. Okay, we gotta load address. Read line routine needs to be read line, I think it's called. Needs to be read line. Something's wrong though, because it read the first one, so why is that? That can't be it. Let's see if this is in there somewhere already. REPL did it. Okay. Oh, before read word. Okay, that's fine. Well, system dictionary is okay, but I don't know about secondary space. Let's see, load address, sec space. Okay, test do it. This does it here. Lsec space init. Do we call that? Yes. Okay. X26. So that's set up. Well, let's make sure. Input. We had an input init. Where's that being called? REPL. Okay. That's called there. That seems a little weird. Load address read line routine. Read line. That really should be set up. Oh, I think input init does that. Gotta look at input. Input init, load address, word pointer. Oh, it does not. Okay. But the first read and REPL. Okay, before reading each word. Well, I think that can move up. Yeah, I'm swirling around here. Okay, let's see who sets up X19. Interpreter. Okay. And tests. And VPC. This should also be interpreter. Oh, interesting. X20. Uh-huh. Now, I don't know why that would have gone away. Right? I mean, you would think eval should do that. Eval. somebody has to. Well, let's look for references to X20. We know we had some that were not legit. Okay, core.s 20. Well, it assumes it's set up. Assumes, okay. I'm going to change these again to match the other comments, but just to make us immune, because if we could change those, we might. And okay, X20. So maybe whoever calls start 2D, right? That's probably the place that needs it. That's different. Okay. So, okay, where do you call start 2D? I think that's got to be in REPL. He calls L evaluate. Not in here. Core load address. That's us. Okay. Interpreter. Start 2D. Run interpreter. Okay, who calls this? Load address. Move VPC. Oh, I guess that's not a load address. Oh, okay. Okay. It always gets started, initialized from the method that's going to run. So, okay. So that much I can live with. Where's this called? Interpreter. Wait a minute. Tests, interpreter, run. Oh, I think we got rid of this. Okay. Make REPL. Okay. 1 dupe add should be 2. Okay. We're busted. All right. Well, I guess we know where to start tomorrow. We've done something, probably something with the interaction. 1 dupe add. Is this really reading more? Dupe add. And nothing's triggering it. Okay. I've got 1 minute. Did we start ourselves in run mode? So REPL, find flags, eval. Oops. Yeah. Okay. Let's initialize that too. Move flags gets run mode. Okay, well, there we go. That wasn't it. All right, we'll start there tomorrow. But I think we've done the basic right the header and we got right the footer. We haven't put the step in the middle where in compile mode it writes the pointer to the definition, but we do need to do that. But I think this demonstrates we've broken something existing in our REPL. So something is not, I don't know if it's not initialized right or what. I really thought the run mode thing might be it, that it was stuck in compile mode. But anyway, we'll pick up there tomorrow. 2 to 4:30 Eastern Time or 6 to 8:30 p.m. UTC. And yeah, I have a no-op secondary. Yeah, I should at least have that. That's what I was hoping for. Apparently I have a no-op everything. All right, anyway, have a good evening. Hope I catch you again in the future. Take care. Bye-bye.